Hey guys, I'm Jay. Welcome to my LeetCode Review One Take vlog on 133rd problem, clone graph. We are given a reference of a node in a connected undirected graph. We need to return a deep copy of the graph, and each node in the graph contains a value and a list of its neighbors. Let's see example 1 here. We got original graph here, 1, 2, 3, 4. First, we can return the same graph. Second, if we clone our red graph here, the nodes were cloned, but the graph is messed up because this doesn't have the same connections as the original one. The new connections becomes 1, 3, 2, 4. Finally, for the blue graph here, this looks like a clone. The nodes are new and graph looks the same. Now, let's start with the intuition. Of this problem. The goal is to clone every node and its relationships in the graph. And we can clone duplicate nodes even if the graph has cycles. To do this, we maintain a hash map that maps every original node to its clone. When we traverse the graph using depth first search or breadth first search, we check if a node has already been cloned. If it has, we reuse clone node. If it hasn't, we create a new clone node and then copy its neighbors. Let's start with a depth first search. In the code, we start by creating a hash map. The hash map maps every original node to its clone node, ensuring that we do not clone a node more than once. Private hash map of node and node. Let's call it visited hash map. We assign a new empty hash map to it. Depth first search and breadth first search. Then, inside the clone graph method, we first check if the input node is null. If so, we return null as there is nothing to process. If node equals null, we just return null. Then, we check if the input node exists in our visited map. If the input node was already a clone, we return the corresponding clone node from the map to avoid duplicate references. If visited hash map dot contains key of node, if so, we just return visited hash map dot get of node. Otherwise, we create a new clone node with the same value as the input node. We also need to initialize the neighbors list as empty because we haven't processed its neighbors yet. So the code is node, clone node is assigned to a new node and with two new parameters. The first parameter is node.value. The second parameter is new empty array list. Next, we store the input node and its clone node into the map. So when we meet the same node again, we could retrieve its clone node immediately. Visited hash map dot put with node and corresponding clone node. After that, we iterate over all the neighbors of the input node. We create a for loop node neighbor and node.neighbors. For each iteration or for each node, we recursively call clone graph on every node on every neighbor node of the input node to clone it. Then we add a clone neighbor node into the neighbors list of our clone node. Clone nodes dot neighbors dot add of clone graph with the neighbor node. Finally, we return the fully cloned node, which represents the deep copy of the original graph starting from the given node. And the code is return clone node. Alright, that's all of the code. Let's submit our code and check if our solution passes all the test cases. Oops, I spelled the node wrong here. Let's resubmit again. Yes, our code got accepted. Now, let's analyze the time and space complexity. The time complexity, it is big O of V plus E. This is because we have visited every node and traversed every edge in the graph for only one time. And V is the number of vertices, which is the nodes, and E is the number of edges in the graph. And for the space complexity, it is big O of V. V is the vertices, which is the node. And there are two reasons. First, the recursion stack in the worst case. For example, a graph with many nodes. And then the visit hash map stores a mapping for every node. Next, let's dive into the breadth first search method. Breadth first search. We'll use a queue to traverse the graph level by level rather than the recursion. First, we still start by checking the bad case. If node equals now, we just return now, as there is nothing to process. Oops. Then we also create a hash map to map every original node to its clone node. So if a node has already been cloned, we can quickly retrieve its clone node from the hash map to avoid duplicate clone. Map of node and node, let's call it visit again, is assigned to new empty hash map. Next, we create a queue of nodes, let's call it queue, using the linked list for the breadth first search. After that, we clone the starting node and initialize its neighbors list. Node clone node is assigned to new node, and the first parameter is node.value and new array list. Then we put the node and the corresponding clone node into the visit hash map. Visit.put with node and clone node. Here we enqueue the starting node to start the breadth first search traversal. Queue.offer with the node. Then we start a while loop that continues as long as there are nodes in the queue. So we can visit every node in the graph. While now symbol queue dot is empty. For each iteration, first we need to retrieve the current node from the queue. Node.node current is assigned to q.paul. Then we create an enhanced for loop to iterate through all the neighbors of the current node. For node named neighbor of current.neighbors. For each neighbor node, if the neighbor node hasn't been cloned yet, we need to clone the neighbor. If not symbol with hash map contains key of the neighbor node. If so, we clone the neighbor node. Oops. It should be called neighbor cloned. Is assigned to a new node. The first parameter is neighbor.value, and the second parameter is a new empty array list. Then we add a neighbor and its clone node into the visit hash map to avoid duplicate clone. Visit hash map put with neighbor and neighbor clone. Next, we enqueue the neighbor node for the future iteration. Q.offer of the neighbor. After that, we need to retrieve the clone node of the current node from the visit hash map. Then we add it into the neighbor list. This step is what connects the clone nodes in the same way as the original path. The code is visit hash map get of the current node neighbors add with visited get of neighbor. Finally, we just return the clone node of the starting node, which is the entire cloned graph. Alright, let's submit the code and check if the solution works. Awesome, our submission got accepted. Then, here comes the time and space complexity analysis. The time complexity, it is also big O of V plus E. This is because we visit every node in the graph for one time and process all the edges. Therefore, the overall time complexity, it is big O of V plus E. V is the number of vertices, which are the nodes, and E is the number of edges. And for space complexity, it is big O of V. Because we create a hash map and the Bradford search queue to help us solve the problem. And in the worst case, we could store all the nodes. And this is the end of my LeetCode review one-take vlog on the clone graph problem. And I highly recommend you guys to visit my online GitHub page here, which contains all the problem description, main idea, intuition, and solution with very detailed annotations code, and the final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the codes and nodes to build this online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.